Have you ever bought a brand new car, loaded with every feature imaginable, only to watch it fall apart before the loan was even paid off? You are not alone. Modern cars are packed with technology that looks incredible on a showroom floor. But behind the scenes, some of these features are absolute reliability nightmares. They break, they cost a fortune to fix, and in some cases, they can take your entire engine or transmission down with them. Today, we are counting down the 25 most dangerous car features that can absolutely destroy your vehicle's reliability. If you are shopping for a new car or wondering why your current one keeps breaking, you need to hear this. Hit that like button, subscribe, and let us get into it. Number 25. Automatic rain sensing wipers. Let us start with something that sounds completely harmless. Automatic rain sensing wipers. The idea is simple. Sensors on your windshield detect moisture and activate the wipers for you. Sounds great in theory. In practice, these systems have proven to be one of the most frustrating features in modern cars. They either overreact to a single raindrop and start flapping wildly, or they completely ignore a downpour like nothing is happening. The sensors use infrared light bouncing off the windshield to detect water, and they are incredibly sensitive to dirt, film, and even windshield replacements. If you get your windshield swapped at a third-party shop and they do not recalibrate the sensor, congratulations. Your wipers now have a mind of their own. The old intermittent wiper switch gave you full control with zero electronics to fail. This is a classic case of fixing something that was never broken and adding a failure point in the process. Number 24. Gesture control. Wave your hand in front of the dashboard to change the volume. Sounds futuristic, right? In reality, gesture control has been one of the most universally despised car features of the last decade. A 2020 report found that gesture control had 36 problems per 100 vehicles, making it the most troublesome automotive technology at the time. The system misreads hand movements constantly. You reach for your coffee, and suddenly the stereo volume shoots to maximum. You scratch your nose, and the navigation screen changes. Multiple manufacturers have tried to make this work, and the consensus from both drivers and mechanics is the same. It creates more distractions than it solves. Physical buttons and knobs worked perfectly for decades, and they almost never break. Gesture control adds cameras, processors, and software that all need to function flawlessly, and they rarely do. Number 23. Electronic door handles. Sleek, flush-mounted electronic door handles look stunning on modern vehicles. They pop out when you approach or press a button, very cool, until they freeze solid in winter, or the motor fails, or the sensor stops recognizing your presence. When a traditional door handle breaks, you are looking at a $20 part and 10 minutes of work. When an electronic door handle fails, you could be staring at hundreds of dollars in parts alone, plus labor, plus potential body panel removal. Some owners have been literally locked out of their own vehicles because both the handle and the backup mechanism failed simultaneously. In cold climates, these handles are notorious for icing over and refusing to deploy. Some manufacturers have even issued recalls over handle failures. All this complexity to replace a mechanical lever that worked perfectly for over a century. Number 22. Automatic start-stop systems. You pull up to a red light and your engine shuts off. The light turns green, you lift your foot off the brake, and the engine restarts. This is the automatic start-stop system, and manufacturers love it because it helps them hit fuel economy targets. But here is what they do not advertise. Every time that engine shuts off and restarts, your starter motor, battery, and engine bearings take a beating. A traditional car might see 50,000 starter cycles in its lifetime. A car with start-stop can rack up hundreds of thousands. Manufacturers claim they use reinforced starters and batteries, but those upgraded components also cost significantly more to replace. Some mechanics report that start-stop vehicles need battery replacements far sooner than expected, And those batteries are not cheap. We are talking $200 to $300 or more for an AGM battery. The fuel savings? Maybe a few percent in city driving. The wear and tear? Potentially enormous over time. Number 21. Electronic parking brakes. Remember the good old handbrake? Pull a lever, set the brake, done. Simple, reliable, and it doubled as an emergency brake in a pinch. Now most cars have electronic parking brakes activated by a tiny button. When this system works, it is fine. When it fails, you are in trouble. If your battery dies, releasing the brake can become a serious ordeal. Some vehicles require a special diagnostic tool just to disengage the electronic parking brake for a simple brake pad change. That means you cannot just do your own rear brake job anymore. You need a shop with the right equipment. Mechanical parking brakes had exactly two failure points: a frozen cable or routine wear. Electronic versions have switches, fuses, wiring, relays, and electric motors that can all go wrong. And because these brakes engage automatically when you shift into park, a malfunction can leave your car stuck wherever it happens to be sitting. Number 20. Sealed integrated LED headlights. In the old days, a headlight bulb burned out. You went to the auto parts store, spent $10, and replaced it in your driveway in 5 minutes. Those days are over for many modern vehicles. Today's LED headlight assemblies are often sealed units integrated into the body of the car. If a single LED element fails, you may need to replace the entire assembly. We are talking $800, $1,000, sometimes over $2,000 for a single headlight unit. And in some cases, the new unit needs to be programmed into the vehicle's computer system before it will function. What used to be a 5-minute driveway repair is now a trip to the dealership. This is one of those features that works beautifully for years and then blindsides you with an absolutely shocking repair bill when it finally does fail. Number 19. Oversized wheels. It used to be perfectly normal for a sedan to ride on 15 or 16-inch wheels. Now manufacturers are slapping 19, 20, even 22-inch wheels on regular family vehicles straight from the factory. They look amazing, no question. But those massive wheels come with paper-thin tire sidewalls that offer almost no cushion against potholes. One good pothole hit, and you can crack a rim, blow a tire, or damage your suspension. Replacement tires for oversized wheels are significantly more expensive, and they wear out faster because there is less rubber to work with. Your ride quality suffers too. Those thin sidewalls transmit every imperfection in the road straight into the cabin. And good luck finding a quick replacement if you damage one of those specialty rims on a road trip. This is form over function at its most expensive. Number 18. Run flat tires. Speaking of tires, let us talk about run flats. The concept is appealing. A tire that can keep driving for a limited distance even after losing air pressure. This allows manufacturers to eliminate the spare tire entirely and free up trunk space. Sounds like a win-win until you actually need new tires. Run flat tires can cost 50 to 70% more than conventional tires. The ride quality is noticeably harsher because the reinforced sidewalls are stiffer. And here is the kicker. Many run-flat tires cannot be repaired after a puncture. You often have to replace them entirely. So you are paying a premium for tires that ride worse, cannot be patched, and eliminate your spare. If you get a blowout in a remote area and your run-flat has already used its limited range, you are calling a tow truck anyway. The spare tire was a better solution in almost every way. Number 17. Panoramic glass roofs. That massive glass panel stretching across your entire roof looks absolutely gorgeous. It floods the cabin with natural light and gives the car a premium, airy feel. It also adds weight up high, reduces structural rigidity, and introduces a whole catalog of potential problems. Some panoramic roofs have spontaneously shattered while driving. Others develop leaks around the seals that send water cascading into the cabin and onto expensive electronics. Models with opening panoramic roofs add motors, tracks, and drainage channels that can jam, break, or clog. When a panoramic roof fails, the repair bill is eye-watering because the glass is enormous and the labor to replace it is intensive, compared to a standard metal roof that costs nothing to maintain and never leaks. A panoramic roof is a beautiful liability sitting right above your head. Number 16. Touchscreen-only controls. More and more manufacturers are eliminating physical buttons entirely and replacing them with a single large touchscreen. On the surface, it looks modern and clean, but there are serious problems lurking behind that glass. Simple tasks like adjusting the temperature or changing the radio station now require navigating through menus while driving. That is not just annoying, it is genuinely dangerous. Studies have shown that touchscreen interactions take a driver's eyes off the road significantly longer than physical controls. And when that touchscreen fails, you could lose access to climate controls, navigation, and even some vehicle settings all at once. A single button replacement used to cost a few dollars. A touchscreen replacement can run into the thousands. Euro NCAP has actually started penalizing vehicles that rely too heavily on touchscreens because they are a safety and distraction concern. Number 15. Keyless entry and push button start. Keyless entry and push button start are now standard on most vehicles. Walk up to the car, grab the handle, press a button, and drive away. Convenient. Also convenient for thieves. Relay attacks allow criminals to amplify the signal from your key fob inside your house and unlock your car sitting in the driveway. Replacement key fobs can cost $200 to $500 depending on the brand. And if the fob battery dies at the wrong moment, figuring out the backup start procedure can be a real puzzle. The electronic immobilizer systems are also more complex, meaning diagnosing and repairing problems requires dealer-level tools. A traditional key and lock was nearly impossible to hack electronically and cost $20 to replace. Technology solved a problem nobody had and created several new ones. Number 14. Subscription-locked features. This one might be the most infuriating trend in the entire automotive industry. Imagine paying $50,000 for a car and then being told you need a monthly subscription to use the heated seats that are already physically installed in the vehicle. This is not hypothetical. This is happening right now. Several manufacturers have experimented with or implemented subscription models for features ranging from heated seats to remote, start to advanced driver assistance. The hardware is in your car, you paid for it, but the software locks it until you pay again. This does not directly destroy mechanical reliability, but it destroys the ownership experience and introduces software dependencies that can brick features if servers go down or the company changes its policies. You bought the car, but you do not really own all of it. Number 13. Drive-by-wire throttle. Older cars had a physical cable connecting your gas pedal to the throttle body. Push the pedal, the cable pulls the throttle open. Instant, direct, mechanical. Modern cars use drive-by-wire, where an electronic sensor reads your pedal position and a computer tells a motor to open the throttle. This allows for better emissions control and integration with other systems, but it adds a noticeable delay that many drivers describe as lazy or unresponsive. More importantly, it introduces electronic failure points. Faulty throttle position sensors, corroded wiring, or software glitches can cause hesitation, surging, or even sudden unintended acceleration. Some owners have reported terrifying situations where their car hesitated during a left turn across traffic. A mechanical cable almost never fails. An electronic throttle system has sensors, motors, wiring harnesses, and software that all need to cooperate perfectly. Number 12. Cylinder deactivation. Cylinder deactivation is supposed to save fuel by shutting down some of your engine's cylinders when full power is not needed. Cruising on the highway in a V8? The computer shuts down 4 cylinders, and you are essentially running a 4-cylinder. Clever engineering, also potentially destructive engineering. Constant cycling between active and deactivated cylinders creates uneven wear patterns. Some engines have developed lifter failures directly linked to cylinder deactivation systems. The collapsed lifters can damage camshafts and even contaminate the oil system with metal debris. Certain manufacturers have faced class action lawsuits over these failures. The fuel savings from cylinder deactivation are modest, maybe 1 or 2 miles per gallon in real-world driving, but a lifter failure and the resulting engine damage can cost thousands to repair. Many mechanics recommend disabling this feature through aftermarket tuning when possible. Number 11. CVT transmissions. The continuously variable transmission uses belts and pulleys instead of traditional gears, providing theoretically infinite gear ratios and improved fuel economy. Some manufacturers have built excellent CVTs that last for hundreds of thousands of miles. Others have not. Nissan's CVT transmissions from roughly 2003 through 2017 earned a particularly notorious reputation for premature failure, overheating, and shuddering. Some owners reported complete transmission failure at under 80,000 miles. The fundamental issue is that CVTs use friction between a steel belt and pulleys to transfer power, and they are inherently less durable under high torque loads. When a CVT fails, repair is often not economically feasible. Replacement is the only option, and that can run $3,000 to $5,000. If you are considering a vehicle with a CVT, research the specific manufacturer's track record carefully. Number 10. Dry clutch, dual clutch transmissions. Dual clutch transmissions promise the best of both worlds, the efficiency of a manual with the convenience of an automatic. And in high-end applications like Porsche's PDK, they deliver brilliantly. But in budget-friendly versions using dry clutches, they have been nothing short of catastrophic. Ford's PowerShift dual clutch in the Focus and Fiesta became one of the biggest transmission disasters in automotive history, with shuddering, hesitation, and complete failures plaguing hundreds of thousands of vehicles. Hyundai also faced lawsuits over their 7-speed dry clutch unit that suffered from overheating in stop-and-go traffic. The problem is that dry clutch systems rely on friction materials that degrade rapidly in slow-speed driving, exactly the kind of driving most people do every day. Unlike a torque converter automatic that can slip smoothly at low speeds, a dry clutch DCT essentially grinds itself to death in traffic. Number 9. Advanced Driver Assistance Systems, Lane Keeping Assist, Adaptive Cruise Control, Automatic Emergency Braking. These systems are supposed to make driving safer, and when they work correctly, they can be genuinely life-saving. But when they malfunction, they are a mechanic's nightmare. These systems rely on an intricate network of cameras, radar sensors, ultrasonic modules, and sophisticated software that all need to be perfectly calibrated. A minor fender bender that cracks a bumper can destroy thousands of dollars worth of sensors behind it. A simple windshield replacement now requires recalibration of forward-facing cameras, adding hundreds of dollars to the bill. False alerts from faulty sensors can cause phantom braking at highway speeds, which is terrifying and dangerous. As these systems age, sensor degradation and software conflicts will create an entirely new category of expensive repairs that did not exist a decade ago. Number 8. Direct fuel injection. Direct injection revolutionized engine performance by spraying fuel at extremely high pressure directly into the combustion chamber. It delivers more power, better fuel economy, and cleaner emissions. It also introduces a serious hidden problem: carbon buildup. In older port injection engines, fuel washed over the intake valves on every cycle, keeping them clean. With direct injection, fuel bypasses the valves entirely. Oil vapors from the crankcase ventilation system coat the back of the intake valves and bake into hard carbon deposits over time. After 30 to 60,000 miles, some engines develop rough idle misfires and reduced power. The fix? Walnut blasting or chemical cleaning the intake valves, a labor-intensive service that can cost $500 to $1,000. BMW, Audi, and Volkswagen engines have been particularly prone to this issue. Some manufacturers now use both port and direct injection to combat the problem, but millions of vehicles on the road right now are ticking carbon time bombs. Number 7. Small displacement. Turbocharged engines. The automotive industry has been on a downsizing spree. Instead of a naturally aspirated 2.5-liter four-cylinder, you now get a 1.5-liter turbo that makes similar power. On paper, it is more efficient. In reality, these tiny turbocharged engines are under enormous stress. The turbocharger itself is spinning at up to 200,000 revolutions per minute at extreme temperatures. If you miss an oil change or use the wrong oil, you can destroy the turbo. And turbo replacement is not cheap. We are talking $1,000 to $3,000 depending on the vehicle. These smaller engines also tend to run hotter, which accelerates wear on gaskets, seals, and internal components. Some three-cylinder turbocharged engines have earned reputations for premature head gasket failures and excessive oil consumption. A larger, naturally aspirated engine, working at a lower stress level, will almost always outlast a smaller turbo engine working at maximum effort. Number 6. Air suspension. Air suspension provides an incredibly smooth, adjustable ride. Luxury SUVs and sedans use it to raise or lower the vehicle at the touch of a button. It is genuinely comfortable. It is also genuinely expensive when it breaks. And it will break. Air suspension systems rely on rubber air springs, electric compressors, sensors, valves, and airlines. The rubber air springs degrade over time from road debris, UV exposure, and simple aging. When they start leaking, the compressor works overtime to maintain pressure, which leads to compressor failure too. Replacing a single air spring can cost $500 to $1,500. Replacing the compressor adds another $500 to $1,000. A full system overhaul on a luxury vehicle can exceed $5,000. Many owners of older Range Rovers, Mercedes S-Classes, and similar vehicles eventually convert to traditional coil springs just to escape the endless cycle of air suspension repairs. Number 5. Over-the-air software updates. The idea of updating your car's software like you update your phone sounds incredibly convenient, and sometimes it is. But the reality is often far messier. According to the 2026 J.D. Power Vehicle Dependability Study, 40% of owners received an OTA update in the past year, and only 27% said it actually improved their vehicle. 58% noticed no difference at all. Worse, some updates have introduced new problems, bricking infotainment systems, disabling features, or creating phantom warning lights. When Volvo launched the EX90 loaded with cutting-edge software, many features simply did not work properly at delivery. An OTA update can theoretically change how your engine runs, how your brakes respond, or how your transmission shifts. That is enormous power, and when it goes wrong, the consequences are far more serious than a glitchy phone app. Number 4. Rear-mounted timing chains. Timing chains are supposed to be a lifetime component, set it and forget it. But some manufacturers decided to mount the timing chain at the rear of the engine, between the engine and the transmission. This means that if the chain stretches or the tensioner fails, which does happen, replacing it requires removing the engine or transmission from the vehicle. That turns what should be a moderate repair into a multi-thousand-dollar ordeal. BMW's N47 diesel engine became infamous for this exact problem. The rear-mounted chain was prone to stretching, and the repair was so labor-intensive that many owners scrapped their cars rather than fix them. A front-mounted timing chain can typically be serviced with the engine in the car. A rear-mounted chain essentially holds your wallet hostage to the manufacturer's design decision. Number 3. Total infotainment system dependency. We have already talked about touchscreen-only controls, but this goes deeper. In many modern vehicles, the infotainment system is not just entertainment, it is the central nervous system of the entire car. Climate control, seat adjustments, driving modes, battery management in electric vehicles, and even some safety features all route through the infotainment computer. When this system crashes, and it does crash, you can lose access to multiple critical vehicle functions simultaneously. Rebooting takes time. Replacement units cost thousands and often need to be dealer programmed. The shift to software-heavy vehicles means automakers now need serious IT expertise, and many simply do not have it. Owners report waiting weeks or months for software fixes. This single point of failure design philosophy is fundamentally at odds with reliable vehicle ownership. Number 2. Aluminum and mixed material body construction. Using aluminum and mixed materials reduces weight and improves fuel economy. It sounds like pure progress, but aluminum body panels are significantly more difficult and expensive to repair than traditional steel. A minor fender bender that would cost a few $100s to fix on a steel-bodied car can easily run $2,000 to $3,000 on an aluminum vehicle. Aluminum cannot be straightened as easily as steel, so panels often need complete replacement rather than repair. The welding and bonding techniques required for aluminum and mixed material construction demand specialized equipment that many body shops simply do not have. This drives up insurance costs and repair times dramatically. Ford's switch to an aluminum body on the F-150 was revolutionary for weight savings, but created a whole new world of repair challenges that the industry is still adapting to. Number 1. Software-defined vehicle architecture. And here it is. The number 1 most dangerous car feature destroying reliability in the modern era. The entire concept of the software-defined vehicle. Modern cars are essentially rolling computers with wheels. They contain over 100 million lines of code, dozens of electronic control units, and an increasingly complex web of software managing everything from engine timing to braking force to suspension stiffness. The 2026 J.D. Power Dependability Study confirmed that infotainment remains the single most problematic category, and mobile phone integration issues have been the top industry complaint for 3 consecutive years. Plug-in hybrids reported 281 problems per 100 vehicles. Premium vehicles are now less dependable than mass-market ones, largely because of their greater technology burden. Every new line of code is a potential point of failure. Every software interaction is a potential bug. The car industry spent a century perfecting mechanical reliability, and in the span of about 15 years, traded much of it for screens, sensors, and software that ages like milk. The vehicles that will last the longest will be the ones that found the right balance between useful technology and mechanical simplicity. That balance is getting harder to find with every model year. And there you have it. 25 car features that promise convenience, performance, or efficiency, but can absolutely wreck your vehicle's reliability. Which of these features has burned you the worst? Or is there one we missed that drives you crazy? Drop your thoughts in the comments section below. If this video helped you think twice before your next purchase, go ahead and hit that like button, subscribe, and ring the notification bell so you do not miss our next deep dive into the automotive world. Thanks for watching, and we will see you next time.